Okay, in the second part of this talk, we're going to look at the activity itself and the response that the students have had in the classroom. First of all, I'll give you an overview of the activity that we've used in the third of those 3 weeks within the unit. And then I'll show you some examples and talk about the students' responses and what I'm thinking in terms of how I can extend their understanding as a teacher, how I can facilitate their conceptual learning. So first of all, the overview of the activity. What is it that we asked the students to do? Okay, so this task was focused on building upon their previous knowledge. They've been working on trigonometric functions. They've done work on other functions and notations, so domain, range, and so on with a function. So we didn't want to spend too much time engaging them in smaller tasks. We thought we would give them a larger task to wrap up the unit. It's also a task that allows us to give them some formative assessment on their techniques and their understanding and their presentation. So we took some of the diploma programme IA, internal assessment criteria, and applied them to this task so that the students could get some feedback and some advice in preparation for their coursework later. So each student had a pack with the criteria, with a task. They also had some guidance about where to take each step within the investigation. So we gave them quite a lot of structure and also some framework within which to write down their observations. But at the end of this process, they were expected to independently write up their own summary of their exploration or their investigation. And they could choose to do that in writing or using a presentation or doing a video. We left it up to them. So we structured the work to start with, but then gave them space later on. The students were engaged in an inquiry, so we didn't give them all the information. They were expected to search and find for the information themselves, and I'll show you in a minute how that starts. It was built upon recent knowledge. They have been using this knowledge to some extent, but not in the same ways in recent work. So it was extending and developing and consolidating the knowledge that they already have, but it was also pointing towards concepts which they haven't yet seen, but which come up later in the year. We also wanted to encourage the use of technology. They need to be able to use a graphics display calculator or a graph plotter in their IA, in their internal assessment. So we wanted to make sure that this opportunity for them to practice doing that wasn't missed. And also we wanted to give them the feedback against the DP criteria. So we've incorporated that into this topic, into this plan. So the students were working with a GeoGebra applet. Okay, GeoGebra, you may or may not have seen this software. It's graphing software, but it allows interactivity. It allows the students to move points. In this case, they are moving a point. The software calculates the gradient at that point, but it gives them the x coordinate as well. So part of the investigation is for the students to generate and plot the coordinates of the gradient along the function. So they go through this process of moving the tangent, plotting the points. Now you can probably see where this is going. You can probably see what we're trying to get the students to think about. But bear in mind at this stage, students haven't even been introduced to gradient functions, or certainly haven't been introduced to differentiation. So this is the starting point, in a way, for the students to develop their conceptual understanding of those things. So as time goes on, the students will start constructing another trigonometric graph, which will be the gradient function of -2 sine x, which is on the board. So we'll now talk about the responses that the students have had to this activity. I'll give you an idea of how they completed the handout we gave them and what the handout contained. So the first section of the handout looked at the prior knowledge, the work that they'd done on, recent work they'd done on transformations of functions. We asked them to summarise this work into their notebook. Now you can see from this example on the board that the student got some key concepts, ideas from those: amplitude, horizontal stretch, translation, phase shift, and so on. But there are some things that we can help that this particular student develop in their knowledge, because they haven't quite, for example, got the spelling correct, and they haven't quite given enough detail in this. Other students would have completed this better, some students may be worse. So that highlights to us as a teacher where those individual students are at. So we can use this to ensure that we fill those gaps in their understanding why they are doing this task. Now the students then were working on the GeoGebra applet, and they were ending up with results that looked like this, perhaps. This is a screenshot from one of the students' own screens. You can see that they've managed to plot the gradient function here, and they've also tried to come up with the equation, the function itself here, but it doesn't quite fit the points fully. But the student has been using the concept of horizontal translations and was able to explain that they used how they translated from one graph to the next. So the opportunity is there to develop the student's understanding of the translations and how that relates to this problem. Obviously, what we want to see is the student coming to other conclusions as well. There might be other answers or other possible approaches. And here's an example of a perfectly fitting gradient function with using cosine. In this case, because the student started with sine, we might question the student and say, well, how does cosine relate to sine? Okay, and that might also bring in an opportunity to talk about translations, again, equivalent functions. And the student might then also come up with this example, which I've made up, which is combining translations there in order to give an equivalent sign. Now, these concepts take place in the classroom, and we talk about them with the individual students, but it's important for teachers to stop from time to time and use the conceptual lens, in this case relationships, to try and focus the students again back on what they're trying to learn and to tie those concepts together. So here's an example of using the Connect Extend challenge I talked about earlier. These are the responses I got from the students, and I recorded them on the whiteboard. So first of all, we talked about Connect. And it was at about this time in the investigation, so it was 3/4 of the way through the first lesson, so about an hour into the investigation. So we talked about what sort of things have you used from your prior knowledge? What are the connections to your prior knowledge? And they talked about the transformations of functions, of course. And they also talked about the use of technology, because they've used GeoGebra in different contexts before. And we also talked about the accuracy of fitting functions. So there are some concepts which they've used before. This little activity, 5 to 10 minutes, helps to reconnect and to remind the students of those. I will talk about the Extend challenge again. So the next part of their investigation, the students were recording their results into a table. So after they've done 5 or 6 different curves, they then record their results in a table. It's kind of normal in a mathematics lesson. And then you can see this student has clearly recorded the functions f of x and g of x, but there are some things with notation that we could tidy up on. So this is an opportunity for the teacher to go to the student and just say, why not tidy up on this? We don't have to say to the whole class, this is how you write your function notation again. We can deal with individual students' misconceptions as they take place or as we observe them within the class. And you can see on this side, they've also got some capital letters, but they've got the functions correct, I think. They follow through and they follow the pattern. So it's an opportunity to ask the student, what's the pattern here? What's happening? Here's a different student, okay? A different student here has got their notation perfect for the function itself, and they've got the expressions and the equations here correct, but it would be nice to see some function notation on this side. However, the presentation is really nice. So this is an opportunity then to praise the student and say, well, if you're thinking about the internal assessment, the coursework as part of the final exam, you need to be able to present your mathematics in this way. So well done. And this is the ideal. Okay, this is obviously what we want students to come up with. And ideally, we would like them to explore some negative values or some fractional values and see if those patterns follow through in the investigation. As part of their workbook, the students also had to try and describe the gradient functions they found in terms of the transformations of functions of sine or cosine that they know from before. So this is again was an opportunity for students to consolidate and develop their prior understanding in this new context. So again, at this stage, I put this slide up again because we stopped again in the lesson. So this was now the end of the second lesson, so about 2 hours, 10 minutes into the investigation. And we did the extend and the challenge. So I asked the students, what new ideas have you used? How has your knowledge and understanding been extended through what you've been exploring? And they were able to identify gradient as a function. Okay, they were aware of what a gradient was, but they weren't aware of what a gradient of a tangent represented as a function was, because we've never talked about gradient functions. So the learning has taken place. They were also talking about the patterns that connected, the relationships that connected the functions to the gradient functions. So they've identified these connections themselves. They can talk about them in terms of transformations, or they can talk about them in terms of coefficients, or some of them can talk about them in terms of the family of functions, sine and cosine, names of the functions. So they were able to make these connections. Okay? Some of them also made specific connections, like why doesn't the d affect the gradient function? And that was an opportunity then to talk to the students about, well, if you translate a graph vertically, why wouldn't the gradient function change? So there are deeper concepts which we haven't even started to talk about necessarily in the units yet, which the students are starting to explore. Finally, we talked about the challenge as well. What do the students view as challenges, things that they still don't quite understand? So this gives the opportunity for students to think about, well, what am I still unsure about? What do I need to think more about? What do I need to wonder more about? What do I need to try more? Do I need to go back and use the applet to try this again, to try and develop an understanding? So this helps, this process, this connect, extend, challenge, which is a making thinking visible routine, helps the students to consolidate their conceptual understanding, to build the links, to build the synergy in their conceptual understanding. One of the last questions in the pack was trying to get the students to think very deeply, It's a very challenging question. Does the gradient function relate to the original function? Can you record your deductions? So students can answer this in a number of ways. Sine becomes cosine. Cosine becomes sine. Well, one of those is not quite correct. A stays the same. Okay, so at this level, for grade level 11 standard level, for students who haven't seen differentiation yet, haven't even talked about gradient functions yet, really, we're not going to see necessarily some very deep answers, but we will start to see some ideas, some connections being made, which we can then encourage in the students. And that can feed into perhaps the next unit. Or when we do teach differentiation, we can come back and remind them of what they've discovered and what they've thought about during this investigation. This one came up. Gradient function does not change even though the value of d. So it's the same one as before. So there are some conceptual connections and solid understanding that the students have developed. So in that brief period of time, I've given you an overview of the activity, okay, and how we used it in the classroom, what the students did. You have an idea of what the students did based on the slides there. And you've got an idea of the student responses. What we would now do is take that information, also look at the students' assessment information. They haven't yet actually written their assessments for this. We haven't seen their final piece of work, but we would take that and assess it as teachers, looking at it through the eyes of teachers marking the internal assessment, give the students some written feedback, but not necessarily a grade at this stage, and hope that will help the students to develop their understanding of the coursework, but also of what they've learned through this process. After that is done, then as a team of teachers, we would follow that cycle, and the three of us as teachers will sit down, talk about the students' results, talk about the results of the assessment, if it worked well, if it was a good idea to allow the students to choose the format of their assessment, and then finally we'll look at the unit and say if there's anything that needs to be changed for next time. So that gives you an overview of the planning process and the concepts and ideas that we try to use within the mathematics department here at this school in this international context. Here's a set of questions that you should think about and look back over. There's some authors that I've made reference to in the presentation. Look up some of their books, think about what they think, look on the website for the Thinking Visible routines, and then try to answer these questions yourself. Thank you.